Christina.
Hi, Susan.
We are talking about discrete probability distributions, aren't we?
That's right. Yeah. I feel like before we talk about discrete probability distributions, we should remind everybody about the difference between discrete and continuous.
That's a great idea. Okay, let's do it.
Yep. So discrete distributions, okay, I get those when I have a variable that is discrete, okay?
Which means we can count it, right?
Right. It means we can count it. If you want the mathy definition, it means that on any interval, there is a finite number of values.
You know what that really means? That means you can count them up on your
Yeah. Yes, I suppose. But I like to, I don't know. I like to think about the mathy definition because when I think about a continuous variable, that's something that's measured on a number line that I can't count all the possibilities.
Right.
On any interval, there's an infinite number of
possibilities. Yes.
Infinite number of possibilities. Okay. So what we're going to look at in our discrete distributions, since they are countable, I can count them. I can also list them out, okay, in a table.
Yeah.
So our discrete probability distributions are going to look a lot like our frequency distributions. They look kind of like a relative frequency distribution.
Okay, because we can list every possible outcome that could happen. That's what you're saying, right?
Yep, that is what I'm saying. Good. So look, check out these couple of examples that we have here. Determine whether each random variable is discrete or continuous. If I'm talking about the number of cars in the parking lots.
Counting.
I can count them up. That's discrete. Right. What if it's the height of a random student?
Measuring.
Yeah, I would measuring it like on a number line. So continuous. So a couple of requirements for a probability distribution. All of the probabilities have to add up to 1. And that's because I have listed all of the possible outcomes.
So therefore, 100% chance one of them will happen.
Yeah. And also, I mean, the second one is a little bit redundant that all the probabilities have to be between 0 and 1 because we don't have any probabilities that are not between 0 and 1.
Exactly.
Right. Good. All right. So this first example here, Susan, I think we should just have them look through this in their notes.
I agree. We talked about this and we want you to either pause this video and read this and study it and understand it, or we want you to go to the key and read this and study it. But this takes a little bit of time to think through, and we need you to spend the time thinking through it.
Yes, thanks. So we're going to actually work through the next example. Okay.
Which is more of a nuts and bolts of just how to do these problems.
Yeah. So this one says a cell phone service has the following distribution of cell phones associated with each friends and family account. So the X value is representing the number of phones on the friends and family account.
Okay, like there's one phone on the account.
Right, exactly.
Okay.
Yeah. And then also, let's go to this explanation right here, okay?
And we have talked about 0 plus already.
I think we did. Yeah, we did talk about
that. But let's talk about it again.
Yeah, so just a reminder, because we are going to put this distribution in StatCrunch, and so just to remember that when you're doing calculations, you can just put a 0 in for the 0 plus.
Yes, don't make up some number. Just use 0 for the calculation.
Yeah, and don't type the plus.
But no.
Because then it won't be recognized as a number. So, okay, good. So when I read the probability distribution, I can answer questions, right? Like, if one account is randomly selected, find the probability of exactly 3 phones on the account.
Okay, so I think if we just go up and look at the row with 3 and a probability is 0.32.
Exactly. And it's important to write out your probability statement.
Yes.
Because that way, you know, you need to practice using these inequality symbols also, right? So it might be exactly 3 equals 3. But, you know, if it's 4 or more, you need to be able to write this as x greater than or equal to 4.
Yes.
Okay.
Yeah.
Because that's what's going to be in your calculators in StatCrunch. You have to use those symbols. Okay. So you need to be able to put the right symbol for greater than or equal to, less than or equal to, between, etc. Okay.
Agreed.
Yep. So for this question, the probability of 4 or more phones.
That means there could be 4 phones, 5 phones, or 6 phones.
Right.
And
so
I hear or, which means addition.
Yes, exactly. So when I add those up, 0.39 plus 0.14, and I put 0 for the 6.
That's right.
Yep.
Just 0.
0.53. Okay.
Yes.
Good. All right. So read through the rest of these and make sure that you understand how to get those answers. Notice the difference between just between, okay, where I only have less thans and the endpoints are not included. And if it says inclusive, then I would use the less than or equal to symbols, and those would be included.
And pay attention on how to write that probability statement, because you probably haven't done a lot of inequality statements in a while. So pay attention to how you write those.
Yes. All right. So just like I can find the mean and the standard deviation of a frequency distribution, I can also find the mean and the standard deviation of a probability distribution. Except that since these are theoretical probabilities and not like actual things that I've counted, I'm going to use the parameter symbols for these.
Okay.
So I'm finding a population mean and a population standard deviation. There's formulas here, but there's also StatCrunch directions.
There's also StatCrunch.
Yes. So we're going to pull up StatCrunch and show you how to do it in StatCrunch. It is not under summary stats, because that is if you have, you know, like physical data from, you know, frequency distribution. So don't try and do this in the grouped or bin data.
Like you did a frequency distribution. Do not. It looks like it, but don't try to do it.
Yeah. Yeah. So instead, we're going to use a new thing. We're going to use calculators under stat, and that's where you find all of the probability distributions. Yeah. Okay. So, so I have that table for the cell phones. I have that in StatCrunch. And I wanted to also point out that that mean is also called the expected value. Okay. And so the mean and the expected value are the same thing. Because think about it this way. If I randomly pick a cell phone plan, how many phones would I expect to be on it? The average, right?
I'm going to expect average. We always expect average.
Right. So on average, I've got, you know, and the answer is 3.5. So let's look at how to get those, okay? So in StatCrunch, if you've got your table in there, okay, then we're going to go to Stat, Calculators, and then Custom is all the way down at the bottom, okay? So my values are my X values, and then the weights are the probabilities. And I can hit compute. Okay, so notice it gives me the mean, and it gives me the standard deviation. And then what else, Susan?
Wait a minute. It also gives you probabilities.
It does.
So if we went back to that page that we just did where we were adding up all those numbers, it would have done that for us. Can we do E?
Yeah.
And then I want to do F and G. Can we do those real quickly? Okay,
yep.
let's do it.
The probability of no more than 2 phones. So that was probability that X is less than or equal to 2. So it's already on less than or equal to. So I'll leave that there. 2. And I get the same thing that I got doing it by hand.
There you go. Okay, let's do these between 2 and 5 and then between 2 and 5 inclusive.
Yeah, because those are going to be a little bit different on this custom calculator. I can't pick the inequality symbol on the custom calculator. So it's set to be inclusive.
Yeah, it is.
Yeah, so I can put the between 2 and 5 inclusive on here, just like this.
Oh, we can get that one.
Uh-huh.
0.98, and that's what we got for G, was 0.98.
That's what we got, was 0.98.
Yeah.
But if I wanted to do between 2 and 5, not inclusive, then
what if we just, for the lower one, what if we just go down to 3 instead and don't include 2?
Yep, that
And
should
then
work.
and then what if on the upper we go to 4 instead of 5, so we don't go all the way up to 5?
Yep, and that gives us the same thing we got doing it by hand.
And if you look on there, we're between 2 and 5.
Yeah.
But we're not including 2 and 5. We're only doing the 3 and the 4.
Yeah, and that graph highlights which values are being included.
If you see color.
If you see color, yeah.
They're red if you see color.
Yeah. So it has the 3 and the 4 are different colors there, and I can see that I'm not including the 2 or the 5. But if I put 2 and 5 on here, oh gosh. I don't know what that was. Then it's between 2 and 5 inclusive. So I'm including.
Got it.
Yep. Awesome. Yep. So that is, let me close this again.
And that's how we get the mean and the standard deviation. They were both given.
Yeah.
On there. And was there anything else?
Would selecting an account with one phone be unusual?
Ooh, 2 different reasons we back up our answer.
Yeah. Yep. So 1 is less than the minimum usual value. If I take 3.5 minus 2 standard deviations, I get 1.6. And also, if I look at the probability, that's less than 5%.
Yeah, because it was like 2%.
Yeah, it was.
Okay.
Yep, it was 0.02.
Yeah.
Okay.
Okay.
That's all I got.
That's it.